I'm just going to run through some examples here in this video of graphs that are undergoing reflection transformations, okay? So what we intend to do here is graph one cycle of each of the following trig functions. We want to identify these things. We want to identify amplitude, if it exists, the period, as well as the domain and range for each graph. So let's go ahead and take a look at this first one here. It says -3 sine x. Now when you graph these, recall that when we talk about trig functions, we're talking about trig functions of the form a times the sine of bx, okay, something like this so far as we've gotten to understanding these things. But we know that if the a value is negative, then we know we have a reflected graph. Okay, so this is kind of what I'm focusing on, these three graphs here. But also this, keep in mind that the amplitude of the graph is equal to the absolute value of the a value. Last but not least, we've talked about the period of a graph before. Okay, when we say the period is typically the original period. So for example, I mean if it was a sine curve, the original period of a sine graph is 2 pi, whereas the original period of a tangent graph would be just pi. But we say you take that and you divide it by b ways. So we're going to get, in this instance, 2 pi over b. So I'm just writing these things out to kind of recall those things, but also to point out that we should always identify the values of, say, a, b, and we're going to have by c and d in the future. But we say, okay, so a in this case is -3, and we have a b value in here. This is the coefficient of our x in here. We say is equal to 1. So before we graph this, we say then the amplitude is equal to the absolute value of -3, which is 3. And then we say the period of this graph would be equal to the period of sine in the first place, which is 2 pi divided by b, which is 1, so we just get 2 pi. So we're identifying these things so that when we go graph this, here's what we always do. We go out one period length past where you're starting from, in this case 0, and then we cut that in half, so this is pi, and then you cut those halves in half, so like pi halves increments. And I notice that the amplitude here is 3, so we're going to go 3 above and 3 below on this graph here. So we say this is -3, this is +3. Then we're just going to use what we know about the basic shape of sine, which is typically starts at 0, goes up to its maximum, back to 0, down to its minimum, back to 0. But in this case, you'll notice that before we graph this, we said the amplitude is this, the period is this. Now we need to ask this question for the first time. We say, is it reflected? And this, I look at this as like a yes or no question. We say yes, no. We say in this case, because our a value is negative, we say a was less than 0. Then yes, we're going to have a reflected graph. So in this case, we're going to have a sine curve with an amplitude of 3, but it starts at 0 and then goes down to its minimum first, then up to 0, up to its maximum, and then back to 0. So this is no more than what we already knew how to graph. It's just that in this case, we have a reflected graph with an amplitude of 3, same period. So we say, let's go over here and look at this one. We identify a. A looks like, to me, this is out here a -1. We say b in this case, b is equal to 2. Okay, so we're going to use these things here to identify a few things about our graph. Starting with this, we say that the amplitude is equal to the absolute value of -1, which is 1. We say the period of this graph is going to be equal to 2 pi over b. And our b value in this case was 2, so we get a period of only pi on this graph. It's only going to take a pi radian input to go through one full cycle. Also this, we say, is it reflected? Okay, and we notice that our a value here is, again, it's negative. So we say yes. And the reasoning here is because a is less than 0. So let's go ahead and put one period length out here. In this case, it's only pi. When you split this in half, it's just got to be pi halves. We'll still cut these into quarters, and then our amplitude here is 1. So I'm just going to call this 1 and this -1. So we're talking about a cosine graph this time. Recall that cosine typically starts at its maximum, goes to 0, then to its minimum, then to 0, then to its maximum over the course of this kind of split up interval subsection here of the number line. But we say, in this case, because a was negative, we're going to start down at a minimum, and then go to 0, and then go to its maximum, and then go back to 0, and then come back down to its minimum. And so in this case, our cosine curve looks like this. So, this would be a good time for you to maybe like pause the video, take a stab at this one here, and maybe restart it. But I'm going to go ahead and go into an explanation of this one. If you want to see it presently, just go ahead and keep playing. So we say a is -1/2. B is going to be 1/2 in this instance. So we've got these identified. So we say the amplitude of this graph is the absolute value of a. So we say the absolute value of -1/2 is equal to 1/2. Cool. So we have the amplitude. We say the period of this graph is period. Now, the interesting thing here is it's 2 pi over 1/2. And that's the same thing as, I'll try to transplant this up here. We say that's the same thing as 2 pi over 1, which is what 2 pi is, times the reciprocal of 1/2, which is 2 over 1. And so multiplying straight across, we get 4 pi. Oh my goodness, the period is up right here. I'll just go ahead and say it's right here. It's 4 pi. Okay, so we're going to go out 4 pi, cut that in half. That would be 2 pi. Cut those halves in half. And then we're going to go up. I'm going to go up to 1. I'm going to go down to -1 here. I'm just going to call these halfway marks, increments, a half. And so we're going to go ahead and graph this. One more thing we want to mention here is it reflected? And yes, it is reflected. The reason why is because a is less than 0. We say yes, it is reflected. So instead of a normal sine curve going up, down, down, up, we're going to go down, up, down. So starting at 0, go down to its minimum at -1/2, up to 0, up to its maximum at 1/2, and back to 0. So you can see that we have an amplitude of only 1/2 on this graph, and a period all the way out to 4 pi. Cheers.